Welcome back to the Explainer. Today, we're doing something absolutely incredible. We're going to crack open the black box and look at the exact moment an AI goes from just reading your words to genuinely reasoning about them. We're talking about Tier 2 of AI operations, how AI actually thinks. So let's dive right into this transformation from reading to reasoning. This is the central mystery we're unraveling today. Think about it. You type out a prompt, you hit send, and boom, almost instantly you get a highly intelligent response. But what in the world is happening inside the AI during those few milliseconds? Well, I want you to imagine a luminous, incredibly complex assembly line of thought just lighting up in the dark. That's exactly what we're going to explore. Here's our roadmap for the Explainer today. First, entering the thinking engine. Second, the attention mechanism. Third, processing and stability. Fourth, depth and emergence. And finally, the final thought vector.
All right, part one, entering the thinking engine.
So the most crucial thing to understand is that an AI doesn't just read your prompt and immediately blurt out an answer. No way. Once it finishes reading the sequence matrix from your input, it genuinely begins to think. Inside the machine, it's like these neon pathways light up as attention, layers, and transformations start refining the meaning of your words step by step. It's reasoning internally before it even tries to predict that first word.
And at the absolute center of this whole shebang is something called the transformer block. You can really just think of this as the core reasoning unit. Every single layer of the model contains this exact same thinking engine, and it has three main jobs. Attention mixes the context, feed-forward networks transform the meaning, and normalization stabilizes it. And what's wild is that this cycle doesn't just happen once. It repeats dozens, sometimes even hundreds of times.
Moving on to step two, the attention mechanism.
Okay, let's talk about self-attention, because this concept is just brilliant. Imagine every single word or token in your prompt looking around the room at every other token. It's literally comparing everything with everything else to figure out which words matter most for its own meaning. This whole process of connecting the dots across your entire prompt, that is the absolute foundation of machine reasoning. But how does it actually pull that off? Well, it happens through this highly mechanical process called QKV projections. Step one, each token gets projected into three distinct vectors: a query, a key, and a value. Step two, the model uses math, specifically dot products, to measure the relevance between these vectors. And step three, it applies a Softmax function to turn those measurements into precise attention weights. This all happens in milliseconds, but this exact mathematical sequence is how the model learns to focus. And what we get from all those calculations is context mixing. Those attention weights act kind of like a heat map of influence. They dictate exactly how much each token influences the others. So nearby and distant words end up fluidly exchanging meaning. The context of your prompt isn't just isolated to individual words anymore. It becomes this completely shared, unified web of meaning. Actually, scratch that, it gets even crazier. The model doesn't just do this one time per layer. It uses multi-head attention. That means it has tons of different attention heads analyzing the exact same sequence in parallel. One head might focus purely on grammar and syntax. Another is hunting for entities, like names and places. Another is looking for those long-range links between the start and end of your prompt. The AI's thinking literally becomes multidimensional.
Section 3. Processing and stability.
Enter the feed-forward networks. Think of these as little mini-brains sitting inside every single layer. Once the attention mechanism mixes the context, each token passes through this two-layer neural network. In here, the representations expand, activate, and then compress back down. Honestly, this is where the heavy lifting happens. The vast majority of the model's raw computational power gets spent right here in these mini-brains. Now, you might be wondering, with all this expanding and compressing, how does the AI not just completely forget what you originally asked? Well, that's where residual paths come in. These are essentially skip connections that bypass the transformer blocks entirely. They act like anchors. They preserve your original signal while simultaneously adding in the new meaning generated by those mini-brains. It prevents information loss and keeps the deep reasoning grounded so the AI doesn't just wander off on a tangent. And to keep the whole system from flying off the rails, we have layer normalization. It's basically an automatic volume knob that keeps the music from getting too loud or too quiet.
Normalization keeps all those activation values in a healthy, balanced range, preventing any one dominant token from just overpowering everything else. It's a crucial balancing act for calm, consistent reasoning. Okay, part 4, depth and emergence. All of this builds up through layer stacking. The reasoning emerges from repeated transformations. It's a hierarchy, right? The earlier layers down at the bottom handle the basic stuff, syntax, grammar. As your sequence moves up, the middle layers start building deeper contextual meaning. And finally, the late layers at the very top form the complex abstract reasoning. In AI, depth literally equals understanding. And that leads us to this massive takeaway. Reasoning is learned, not programmed. Human engineers did not sit down and write the code for logic. Instead, the model learns these reasoning patterns purely from analyzing mountains of training data. Induction heads just naturally learn to detect structure. Chain of thought traces emerge organically. It's wild. The logic is an emergent property of the system itself. Now, we've talked a lot about the classic transformer, but there are actually different ways of thinking emerging right now. If we compare a few architecture variants side by side, we see transformers think by comparing everything with everything. But newer models like Mamba, they think step by step using a specialized memory. And Jamba mixes that global attention with fast recurrence. The mechanics are different, but the end goal is always the same: clearer, faster, more accurate thought. And finally, part 5, the final thought vector. So, as your sequence flows upward through all those dozens of layers, we see the thinking loop in action. With every single pass, the understanding gets sharper, ambiguity just fades away. The context strengthens. The model's internal idea of what you are asking becomes immensely precise. Then, right at the end, after passing through every layer, the model crystallizes everything into a single, glowing final thought vector, emerging from the very top. This one vector contains absolutely everything the AI understands about your prompt: the context, the meaning, the intent, all of it. It's the culmination of the entire assembly line, and it is the absolute basis for predicting the very first word of its response. Which leaves us with a really profound question. We just walked through a purely mathematical, mechanical assembly line of queries, keys, and vectors. Yet the output looks remarkably like human reasoning. If this mechanical choreography happening inside our devices right now is how AI thinks, what does that mean for the future of human intelligence? Are our own thoughts just some biological version of layer stacking and context mixing? Definitely something to chew on the next time you press send. Thank you so much for joining me on this explainer, and I hope it sparked your curiosity to learn even more.